The purpose of this video is to show you how to use a CAD program like SolidWorks to model an aircraft. There are many CAD programs out there. Most of them work about the same as SolidWorks, so that if you understand what we do in this video, you can probably transition to other CAD programs if you need to without too much trouble. We'll show you just the basics. There are many things that a program like SolidWorks can do, and we will show you only the basic functions you need to draw an airplane and that you need to use in this course. We'll begin by creating a new file. We'll go File, New. It's going to be a part file, so we say OK, and then it will create the environment for us. We don't really see much yet because we haven't drawn anything. We do see the coordinate system, and that's important to us because this shows us what SolidWorks thinks is a front view. In fact, if you go up here to the little view selector and take a front view, you'll see what happens down there. We're looking at the X and Y coordinates, or axes, the XY plane, from the positive Z direction, and that's what SolidWorks calls a front view. But if we think about our aircraft coordinate system, we have the X-axis moving from the nose of the aircraft down the longitudinal axis towards the rear of the aircraft, and we have the Y-axis going out the right wing. So looking at the XY plane from the positive Z direction would be a top view for us in aircraft terminology. Now, it's not a big deal. We have to keep track of the differences. We want to keep our X and Y axes the way they are normally defined for aircraft. We don't want to draw according to the SolidWorks orientations, because that would then be confusing when we try to do other aircraft things with our aircraft model. So let's just keep it this way. Realize that there are different names for the different views, and we'll just have to do the translation in our head. So this is a top view of the aircraft. To start drawing an aircraft, we need to start by drawing the wing. And the way we'll make the wing is with a function called lofting. Now, the function like that is called a feature. Go up here and we hit the features tab, and you can see there's lofted and extruded things, and we're going to do both of those. We'll do some extruded cuts, but to do that, before you can do any of those things, you need to have a sketch. The way you define solids in SolidWorks and most other CAD programs, solid modeling CAD programs, is you draw sketches, and then you either loft them by connecting two sketches with a solid, or extrude them by taking the shape of one sketch and stretching it out into a solid. We'll show you both those ways of doing things in this tutorial. That's really most of what we do in drawing airplanes, and we'll make that clear as we draw our airplane in this program. So, to start out, we want to draw an airfoil shape at the center line of the aircraft, our root chord, if you will, and we need to sketch that in a plane that is y equals 0 plane. If you think about what y equals 0 plane would be, that would be what they'd call a top plane. And the view we would want would be not from the positive y direction, which would be a top view. We want it from the negative y direction, so that we're looking from the left side of the aircraft towards the right side, with the z-axis positive up as we draw our airfoil. So let's do that. That would be a bottom view. Okay, there we go. X is positive this way, z is positive that way, y is going away from us. And that's exactly what we want to draw. So we want to draw in this plane. We have sketch selected. We're going to start by drawing a spline. Okay, and for some reason, when I did that, it flipped it over, so I'm going to flip it back. I don't know, now there's Z positive down. I want Z positive up, and that's how I want to draw. So for some reason SOLIDWORKS did that to me, but I'm not going to let the program tell me what to do. So I'm just going to draw the top of an airfoil. The spline is, real splines in drawing, in mechanical drawing, are flexible steel rods, very slender rods that can be bent to go between points on a drawing board. And so what we're doing is defining points, and the math of a spline is used to define the lines here that define our airfoil. This is going to be a fairly thin airfoil. I'm making it go out pretty far. It's got a little bit of camber. That's my upper surface. I'll hit escape. Hitting escape exits the drawing of that spline, and now to draw the lower surface I go back and select spline again. So now to draw the bottom of the airfoil, I select spline again. I'm going to keep it a pretty slender airfoil, so I'm going to stay real close. And of course, if you were actually drawing a aircraft that you had defined either by a sketch or in the JET software, you would know how thick the airfoil had to be, and you have specific dimensions. I'm doing this sort of ad hoc without specific dimensions. Now I'm keeping the trailing edge blunt. The program tries to snap to a sharp trailing edge, you can see there, but I'm pulling away and not allowing that to happen, because when I go to 3D print this thing, if I have a sharp trailing edge, the resolution of the printer will cause me to lose some of the planform area back there. It just won't print because the thickness of the bead that the 3D printer's laying down is thicker than the airfoil back at the trailing edge. So this way we keep our full planform. Yes, we have a slightly thick trailing edge, but that's better than not having the proper airfoil shape. Now I can refine this a little bit by zooming in, and to zoom in I'm rolling the scroll wheel on the mouse, and this is very, very convenient to do that. And I'm just going to drag this down a little closer so I've got a thick trailing edge but not, and hit that, and somehow, there we go. And then I'm going to draw a line between those two. When you zoom in and out, it zooms on the point where your mouse is. So you can, so there I selected line, I clicked on one point, clicked on the other point, and now I hit escape to stop drawing lines. So if I want to see more of that, I put the mouse over there and it zooms in on that point. Notice it continues to zoom in. You get used to this pretty fast, moving around your view by just scrolling in and out on the scroll wheel. Please, if you, likewise, to change the orientation of your view, you push down on the scroll wheel and move your mouse around, and it becomes very natural to look at different views, oblique views, etc. of your drawing. And so please, if at all possible, get a mouse. You'll thank yourself a million times for doing so, because it's so much easier with a mouse. Don't try to do this without a mouse. Alright, and I'm also going to pull these 2 points apart just a little bit. Until the sketch is saved, you can, well, at any time when you're in the edit mode, you can modify the sketch and pull the points around to get a better shape. Now, I'm going to finish by, first off, let me get that bottom view again and zoom in on this part of the airfoil. I'm going to draw a leading edge. I'm going to do it with 3 points on a spline, and that doesn't look right, does it? I'll hit escape to stop drawing splines, and then I'll drag this point to make the airfoil nose look about right, and that looks pretty good, I think, to me. That looks like an airfoil to me. Maybe this back here isn't quite right. Maybe well, that was too much. It kind of jumped on me. And you can drag, that's how splines work, you can drag the points around. You can also, you see how when I clicked on this point, these tangency indicators pulled up, and I can adjust those as well, and I can actually make them different from each other so that there's actually a sharp corner at this point. This just makes a nice airfoil shape, I think, here. Likewise, I can force this at this point to be tangent. The spline's just following the equations of a flexible metal rod, putting the line through the points in a smooth fashion. So that's my airfoil shape. As I said, it's quite a thin airfoil. Once again, checking, I've got X in the positive direction from left to right. I've got Z positive up, and Y is away from me, out the right wing. So this is the root chord. Then I'll go out the right wing and make a tip chord, and then I'll loft the wing. I'll hit exit sketch here because I'm happy with this drawing, and then I need to define another plane out at the wingtip to draw my wingtip chord and then do the loft. So to define another plane, we have to figure out what it's referenced to. So I click on that top plane again, and then I go up here to the menu and I select Insert Reference Geometry Plane. It says in millimeters. Okay, well, so I'm not in millimeters, or I don't want to be, so I need to change the units. So let me X out of that and do that first. And then let me scale it up to a full-size airplane before I start making the rest of the wing. So first, to scale, change the units, I go to Options here. So I went to Tools, Options, Document Properties, Units, and I select inches, pounds, and seconds. Okay? So it makes that change. And then let's go back into the sketch. I right-click on the name over here in the list, and I select Edit Sketch, and I want to see how, in this bottom view, how long this airfoil I drew was, because I just drew it kind of ad hoc. One way to do that is to draw a line from leading edge to trailing edge. That would be a chord line, we would say, in aircraft nomenclature. And if I click on that line, it says it's about 8 inches long. Well, we want a lot more than 8 inches. We want maybe 20 times that much for a typical aircraft root chord. So let's, instead of having 8 inches, let's have 160 inches, or a factor of 20. A little more than that. Maybe I'll go 25 for a scale factor. So first off, I highlighted that line I drew. I don't want it to be part of the sketch. And I hit escape, or I hit delete, and delete that line. The reason I don't want the line to be part of the sketch is when we do lofts, the sketches that go into the loft have to be closed curves. They can't have any extra little lines drawn anywhere. They have to just be simple closed curves so that the loft function can figure out what to do. Alright, so this is way too small. So I want to scale it up by a factor of 25. And so, again, you would have a specific dimension you were drawing to. I'm just showing generic. So we do the drop down on Move Entities, and we can say Scale Entities. And then it says scale about what point? Well, let's scale about that point. It automatically had highlighted that. What's the scale factor? Let's say 25. And then we hit the green checkbox, and it shows it. And we say we like it, and we're done. We say we like it by hitting the green checkbox again. Okay, I like this. 25 times 8 is 200 inches. For a root chord, that's a typical fighter airplane root chord. So that's a decent size to draw this model. Alright, so we're happy with the sketch. We can say exit sketch, and now let's define that. Go back to the top plane. Let's define our new reference geometry for the wingtip. It's going to be a plane. It's going to go out. What's a typical wingspan? Well, so a 30-foot wingspan is typical, 30 to 40 feet. So 30 feet is 360 inches, and half of that is 180 inches. So let's go 180. Okay, that's pretty reasonable. That looks like a pretty good wing that we'll be defining. And so let's check that. Alright. Now what we're going to do to save our effort is we're going to take this sketch. We clicked on it. We're going to go Control C, and they're going to click on that plane out there and type Control V. And that'll put a copy of the sketch onto that new plane. But we don't want a Hershey bar wing. We want a tapered, swept wing. And what I'm going to do, the F-16, the trailing edge of the F-16 is at a constant X location. So what I'm going to do is I'm going to scale down the wingtip using this point back here at the trailing edge as my scale about point. And it'll shrink that leading edge down and give me a swept wing and also a tapered wing. That's what I'm going to do. So I right click on sketch 2, I highlight the whole thing, and I didn't get it. Highlight the whole thing. You can tell it's highlighted because it turns a lighter blue. I'm going to go Move Entities, Scale Entities. I'm going to scale about this point back here, and I'm going to do a scale factor of point. Let's see, let's say the wingtip should be 1/10 as big as the wing root. So I can just type in 1/10 and hit enter, and there it is. That's a taper ratio of 0.1. I hit the green checkbox, and let's hit it again just to make sure it's all happy. And now I've got a wingtip out there. Actually, let me go back and change that, because the taper ratio of an F-16 is 0.21. I know that. And so instead of 0.1, I want it to be 0.21. Well, I could just Control Z the last few things I did, but I can also just scale this back up by a factor of 2.1. So I'll just do that instead. Move Entities, drop down Scale Entities, scale about that same point there, and it's a scale factor of 2.1, and hit the checkbox. Now we've got an F-16 kind of wing plan form, I would say pretty close. Alright, so we're happy with that. We exit sketch, and we're ready to loft. I'm zooming in enough so that I can see the points I'm going to use in my loft. This is a little bitty thing, so I want to be able to pick the point. I'm going to use this point here as my same point on both airfoils for the loft. So I go to Features, Lofted Boss Base. I click that point there, and then I have to go see the other one. Remember, it zooms in and out based on where the mouse is, and so it becomes really natural. So here's the next point right there, and that's the loft I want to do. It looks right. I zoom out, make sure, yeah, it looks kind of like an F-16 wing. And I'm going to hit the checkbox, and there it is. Now suppose we didn't want an F-16 wing. Suppose we wanted something more like a stealthy airplane. Well, we could move the wingtip about with that move function. We could change that sketch. We could change the root chord as well. Let's do that just to show that how it could be done, and to get a stealthy wing that doesn't have a trailing edge at 90 degrees to the oncoming radar waves. So that move function normally is an XY thing, so let's do that first, I guess. And the way we have to do that to edit those sketches is we have to expand out the loft. The sketches have been consumed, so what that means is if I click over here, the sketches are not visible anymore. You can make them visible. You could say sketch 2 and see the little eyeglasses, and now it is visible. But the default is when it's been used to define a solid, a sketch disappears. And that's okay by me. I'll let that disappear. But I do want to edit it because like I say, want to change its location so that the trailing edge is not perpendicular to the oncoming radar waves. So now I went into the edit sketch. I highlight the whole thing. I'm going to move entities. I don't have to hit the drop down because move is the default, and the delta X is going to be negative, so let's go negative 20 inches and hit enter. You see that it moves as a preview. Hit the green checkbox and again, and exit sketch, and it'll redraw the wing. And now if we take a plan form view, which is a front view, we'll see that the trailing edge is no longer perpendicular to the oncoming radar waves. We're even going to make that more the case by stretching out the airfoil on the wing root. And so let's edit sketch 1, right click, select the edit. And in this case, all I'm going to do is stretch out this trailing edge. I'm going to do it just by pulling on the vertical line, and that stretches out the airfoil. Check that, see what that looks like. That'll be okay. And that just shows, and then green checkbox, exit sketch. That just shows that pretty much nothing you do in SolidWorks is final. You can always fix things and redraw things. What if we decide the wings has too much span? Maybe it needs to be smaller. We could change the plane. Right click on that, go to the way we defined the plane, and instead of 180 inches, make it 160 inches. Hit the checkbox. We did that before we had anything defined. And now the wingspan's only 160 inches. So there's all these things you can see there. If we click on the plane, it shows the 160 inches. So we can get whatever we need for our wing plan form. And don't be satisfied. You can always make it do whatever you need it to do in SolidWorks. Okay, so we've got half a wing. Let's easily make the other half of the wing. We're going to mirror it. We select that top plane again. We go up here in the Features tab and select Mirror. We click on this as the thing to mirror. We get a little preview. We hit the checkbox. And now we have a whole wing. Okay, so that was pretty easy. Alright, so now let's make a fuselage. So it's a different plane. It's the right plane, and it's located here. It's arguable that we should have the same x coordinate for everything that we did in our jet model of the aircraft, if we have one. That's easy to do by just moving the sketches downstream to the point where the wing is said to start in jet. And as a way of showing how you would do that, let me actually make that change. Let's say that wing is at 20 feet in jet. Okay, and so we want to move this wing back downstream 20 feet. Okay, so we go to sketch 1, we edit the sketch, we highlight the whole wing, move entities, plus X, we're going to go 20 times 12 inches. We hit enter, that's how far it went. We hit the checkbox, again, exit sketch, and it'll draw the new wing, which is now more like an X29 wing, right? Forward swept. But we'll move the wing tip back as well. Edit, highlight, move entities. We're going to go 20 times 12 and hit the checkbox. Seems like twice. Exit sketch. And now our wing is back where it should be based on our hypothetical drawing in JET. You can make this look exactly like what you have drawn in JET. Now at this point, I want to define a plane at the wing, well, at the point where the wing exits the fuselage, so somewhere back here near that point. And so I get my right plane, which is the front of the aircraft. That's right plane is the nose of the aircraft up there, and I'm going to create a reference plane, reference geometry plane, and it's going to be more than 160 inches back. That was 20, so let's go about 23 feet, 23 times 12. That's about where I want to be for my first fuselage frame. I'll show you why in a minute. So I hit the checkbox, I got my plane, I want a side view of the airplane. You get a preview there as we try to figure out how this all works between SolidWorks front views and aircraft front views, etc. The previews there are very helpful. The side view is a front view in of the aircraft in SolidWorks. And so in this plane I'm going to draw a fuselage cross section. It's not going to be an F-16 fuselage cross section. It's going to be more of a stealthy airplane cross section. Stealthy airplanes tend to have kind of slab sides. And I want it to intersect the wing right about in the middle of the wing here. So I zoomed in, I'm on that plane, I'm going out here. Fuselages tend to be 10 feet wide, something like that. So if I go out here 60 inches, I'm 5 feet is half of that, so that's, and then I go down here again, typical stealthy airplane like an F-22 sloped fuselage side, and then I come back here to the center line and back up, and that's not a bad half a fuselage. I want to stop drawing lines. It's selected up here, so I hit escape, and that is my fuselage cross section. Now there's a couple of things. I want to mirror this to ensure that it's has bilateral symmetry, and these little green locks for certain points sometimes are helpful. Most of the time I don't use them, so I just delete them. You highlight them, they turn blue, and then you hit the delete button. I want to make sure these points are at 0, and yes, that's at 0. It's parallel, so this one would be at 0 y coordinate. Alright, so now let's flip it. So we've highlighted the whole thing. We're going to mirror entities. It says mirror about what point? About this line. And mirror about that line. We're making a copy. I say yes, that's what I want. Now I don't have a simple closed curve though. Now I have this extra line that I have to delete. And there we go, just like we deleted that line we used for measuring when we were drawing the airfoil. So now I have a sketch. I'm going to extrude that into part of the fuselage, so exit sketch. I click on that sketch, I go to Features, Extruded Boss Base, and I'm going to extrude back in the positive x direction, let's say 20 feet times 12 inches per foot. Yeah, that's pretty good. Okay. So that's my rear fuselage. Got my airfoil, my rear fuselage. In some ways, it seems like the wing is sitting a little too high on the fuselage. I don't like, for a stealthy airplane, I don't like this right here. And I don't like this right there. I need to move those down a little bit. And I'll do it by moving my sketch rather than the wing, because to move the wing I have to move 2 points, or 2 sketches. Move the fuselage, I only have to move 1. So I'm going to drop that down. I could measure how much. Here's one way to measure. There are other ways to measure, but here's one way. This is a flat plane, so I can sketch on it. Now generally I don't sketch on faces, but in this case, since I'm going to delete it anyhow, I do. It's about 3 inches. That's what I was guessing. Okay. Yeah, it's about 3 inches, so I'm just going to lower the fuselage sketch 3 inches. So I'm just highlighting the whole thing and deleting it. Exit sketch. That was just to see what's happening. So I'm going to move this sketch here. That sketch is, there's nothing in it, we just delete it. Oh, I have to exit sketch. It wouldn't let me delete it because I hadn't hit the exit sketch button, but when I did hit the exit sketch button, I hadn't drawn anything. I deleted what I drew, so it automatically deleted the sketch. Let's go back here to sketch 3, edit it, highlight it. We want to move it minus. Okay, so we're in a different plane. Y is, I think, positive or positive up. So I'm going to go -3 and see if that's right. Nope. So that's not right. When you start drawing in other planes, our nice X and Y axes don't work, and so sometimes there's a little trial and error. Let's try -3 this way. Yep. And then so it's +3. So it was what I said, positive, and you see these little axes here, positive down and positive right. So +3, and I can double check to see if now I'm getting the right, and look, it's not quite what I want yet. I want it maybe just a little bit lower, so let's go 3.3, 3.4. That's about what I want it to do. Let's try that. And exit sketch. And there we go. See, that's how I want the fuselage to meet the wing. And back here it looks pretty good too. There's a little bit of a gap underneath it now, and we'd want to fill that out for a really nice stealthy airplane. So we could build a little piece to fill that in later on. Alright, so we got our wing mounted on, we've got a chunk of our fuselage, we've got the wing on the fuselage. Now we need to draw the front part of the fuselage, which is going to be created by lofting. So let's go back to the right plane. Let's create 2 more planes. Insert reference geometry plane, and we're going to go, let's just go 76 inches. Again, I'm just picking these arbitrarily. You would have specific locations for fuselage frames if you were drawing this from a drawing in JET. Let's go insert reference geometry again. Plane, one more plane about that far, and maybe one more. Yeah, maybe one more. And reference geometry plane. There we go. So that's enough to define our fuselage. I'm going to start the first fuselage frame here in plane 5 as being an exact copy of sketch 3. So I'm just going to Control C, click on the plane, Control V, that's our sketch 3, and I'll loft it. Then we'll have to narrow down so that there's a place for inlets, and then narrow down again for the nose. So let's do that. We'll go, we'll first paste it into here, and then we're going to scale it down. Or in this case, I think I'll keep it, I think I'll scale it manually. I'm going to distort it, make it a lot narrower, but not a lot shorter in height. So I'm going to take these things and move them in like that. Okay. And these 2 points should have the same coordinate. So this is 15. Let's just copy it here. Let's do the other one. I like the other one, a little narrower. So 14. Copy that, and then go over here to this one and paste in the same 14 point whatever. Okay, and hit enter. And now that's correct. Do the same thing up here. 37, and this one is 39, so let's go back over there. 37, copy it. 39, not minus, or make it minus. Okay, so we've moved those in the same amount. Let's make sure the x coordinate in this case are the same. They're not. So those are good. 1.07, 1.02. So let's copy this and make this 1.02. Okay, so now both points should be the same. They're the same numbers. If I want to make more adjustments, I can. I want to bring up the bottom a little bit here. So I'm going to, because it's got the parallel lock on it, it'll move both points up the same amount, keep everything else the same. That seems like a pretty good next point on our aircraft. And then the last thing I'm going to do, well, I've got 2 more planes. Even though the right plane is not showing, that's where the nose of the aircraft is. That's the 0 coordinate. So I'm going to do one more like that shape and then taper it down to the nose. Hit the check box, exit sketch. Sketch is good. I'm going to copy sketch 6 and put it on plane 3. And then you'll see how that'll define, just imagine connecting those lines, how that'll define our nose. Alright, and then on the right plane, I put that thing again, but I have to reduce it very small. Okay, because that's the point of the nose. You can't do a, well, you can do a loft to a point, but again, we wouldn't want to because of the 3D printing. If we lofted to a sharp point, then we'd lose some of that because of the resolution of the 3D printing. So we just want to make it a very small cross-section at the nose rather than coming to an absolute point. So the way we do that is we edit the sketch. go into that thing. I'm going to do a front view now, which is a side view in SolidWorks. I've got it highlighted. I'm going to scale entities. I'm going to scale about this point for now, and I'm going to make the scale 0.01. That's really small, but it's not. It's 1/100th the dimensions, right? But it's still there. Most of these CAD programs are infinitely zoomable, and I have to hit the green checkbox. I'm happy with that. Infinitely zoomable, so you can never make it too small to work with or see. You can always zoom in more. Now I want to move it down to put it more on the center of the fuselage, right about there. And so I'm going to move entities. I don't think it's -y in this case, but we'll see what it is. -15. Let's see where it actually goes. Okay. And again, notice the coordinate system there. It looks like positive X, so I'm going to go 15 down. There we go. That's probably about right. That looks pretty good. Maybe I'll go 20 down. Okay. That's what we're going to do for this demo. Okay, checkbox a couple times, exit sketch, and now we've got our loft set up. We're going to loft from this cross section to this cross section, and then down to these guys and into that point. So that's what the loft is going to try to do. We'll see if it can do it. There's a lot to be said in a lot of cases to loft just one section at a time. But just to show you what can be done, I'm going to loft it all in one piece. So let's try. We need that sketch here and this extruded boss, so it's sketch 3. We'll highlight that and then we'll go lofted boss base. And I'm going to click on here, and it's going to say, no, that's a terrible point. That's even worse. What point is it using? It's using the point down there. Okay, that's good. Now we've got a nice smooth loft. Then I'm going to click on that point, and that point, and this point. Okay, so that's what you can do. It's spline surfaces, defined by the same math pretty much as the splines, only now they're spline surfaces through lines instead of points, and that makes a pretty interesting shape. What I'm going to do here is take out sketch 3, and we're going to make that a straight loft so that we keep our fuselage slab-sided behind the inlets. We imagine the inlets being here somewhere, and so I'm just going to right-click and delete that. And now that's the shape of my nose section, and then I'll put a different loft in there to join the two. So do that. Okay, and then I could actually extrude, but I'm going to loft between sketch 3. I could also extrude because I want this to be constant cross section. And that's not what I meant. Okay, so sketch 5 is also not visible, so I'm going to make it visible to make it easier for me to do this loft. And I guess while I'm at it, I'll make sketch 3 visible. And now this loft will be a piece of cake. Lofted boss base, you click on that, you click on that, and you hit the green checkbox. And now we've got our fuselage, forward fuselage. Okay? Rear fuselage, I'm going to do a different way. I'm going to make my rear fuselage, I'm going to actually lengthen this extrusion a bit and then cut away part of it. So I'm going back here to this extrusion boss extrude 1, right click on that, edit that, and instead of going 20 feet, I'm going 30 feet, so 360. That's enough. Okay, and I'm using numbers that are just, I know, are typical of aircraft, so that's why I'm getting away with just making up numbers in my head. And now I'm going to, well, first off, let's make these sketches disappear again, because they're kind of distracting. That's not what I wanted to do. I wanted to make it disappear. So exit sketch. Let's try it again. Just wanted to make it disappear. Okay. So I'm going to go to that top plane, get a top view of the aircraft, or maybe I want a bottom view so the airplane's right side up. And I'm going to just draw a shape that'll cut away some of the rear fuselage here on this airplane. I have a high wing and I want the butterfly tail to be a high mounted butterfly tail. And I want to be able to rotate easily for takeoff, so I'm going to cut away bottom side of this fuselage mainly. Alright, so I'm going to go sketch. I'm going to just, I could do the spline or I could do lines. I guess I'll do splines. So I want to start running parallel here and then just bend it up like that to make my rear fuselage. Okay, and like that. Hit escape. That's way too sharp, so I need to start, delete these locks that just automatically appear. I need to start much further forward here and bring this up like that so that I have a much more gentle. And I can use this to make it tangent down there. I could also use that one to make it tangent down there. More gentle taper of this rear fuselage. Imagine the engine sticking out down here or something like that. Alright, so that's what I'm going to do. Let's check that. Again, I'm going to turn off these locks. Well, that's a pretty decent thing to do. But remember I have to make it a closed curve, so now I just make a box here and close it up. I'm going to delete that lock and exit sketch. And now to make that rear fuselage shape, I'm going to extrude a cut. So I select Sketch 9, Features, Extruded Cut, and it's going to be mid-plane so that it goes both ways. And I hit the checkbox, and now I've got my rear fuselage. Okay, so this is my stealthy airplane. The only thing I have to do now is add, I could add strakes up here. I could add butterfly tails. What I am going to do is add the strakes. The thing about stealthy airplanes with twin inlets, and all stealthy airplanes I'm aware of have twin inlets. Nobody's trying to be stealthy with a single inlet on the underside. So the thing about twin inlets is that they have to be chined. That means they have to have a sharp edge on their outer edge in order to minimize their radar cross-section from the side. Well, aerodynamically, that means that you have this inlet extending ahead of the wing, and you can't put the inlet right even with the wing because there will be too much distortion as the wing changes angle of attack. So you have to extend the inlets ahead of the wing, and then when you do that, you automatically get strakes, essentially. So what I'm going to do for this model is I'm going to define strakes as the top of the inlet. Then if we wanted to, using the methods we've already seen, we could draw the rest of the inlet. So I'm going to draw those strakes as an extrusion, okay? And the way I'm going to do that is I'm going to find the front plane, right? Let's see where that is here. That's at a pretty good location relative to the wing. And so I'm going to make my strakes by drawing a sketch in the front plane. So here we are. We're going to get a top view, which is a front view. Okay. And then we're going to draw half the strake and then mirror it. Okay, so I'm going to sketch. I'm going to just do a line. Start the center line, go out here to the edge, go forward here a ways, try to go parallel like that, come back here, and I've got it. I'll hit escape, so I stop drawing lines. I'll check the angle of this one, which is, let's just make it 52. Well, no, it's 52.2. I'll check the angle of this one, and it's 270 minus 52.2. That didn't work. So 180. Let me Control Z out of that. 228, 180. Yes. Okay, let's try it the other way. 180 plus 52.2. There we go. We got a parallel line. It's measuring the angle from the other way, and that's why it's 180 out. But it's because of the way we drew the line in order around the strake. So that's my strake. Let's make sure that get rid of these locks again. Make sure that it's still inside the nose. It is. I think it's okay. I think we'll be okay. We could probably move it back a little bit here so that we're sure it stays inside the nose of the airplane. We're going to extrude down. This is the highest the strake's going to go. And yeah, we like that. Okay. So that's our strake or our inlet, depending on how you think about it. We have to mirror image it. So highlight, mirror entities, mirror about this line. We are making a copy. Mirror about this line. We are making a copy. Hit the checkbox. There we go. We delete the center line so we have a simple closed curve. And there's the top of our strake. Okay. Exit sketch. And now we're going to extrude that down to form our strake slash inlet. So we select the sketch, features, extruded boss base. We're going to reverse directions. We're only going to go maybe 40 inches instead of 240 inches. And this is actually kind of a cool way to make a strake. Watch this, or make an inlet. I can taper that and do it enough so that it stays inside the fuselage. You can see that happen because it'll start to disappear. You see right there where it disappeared inside the fuselage. Okay, so that's what we want to happen. And then I could go down even lower, go farther, maybe 50, and I've got an inlet as well as my strake. Well, there's lots more to do there in making that look good. I'm going to go more than 24 degrees. Certainly a good inlet would be angled back more than that. Then we'll show you in another program how to draw an inlet more accurately. That's how I'm going to define my strakes for now. And that shows you another function that's available to you. And that's what I'm going to call my stealthy airplane fuselage drawing. Only thing left to draw are the butterfly tails. and other changes to prepare it to be a wind tunnel model. But what we've shown you here are the basic functions that you need to be able to do in SolidWorks. I'll show you just one more thing. I'll show you an extruded cut to show you how we might make a hole for the engine. Okay? We would also extrude a cut or a loft to create the inlets, and it's done much the same way that the other lofts are done, only it's cutting away material instead of adding in material. And to do that, we need a place to start. I'm just going to use this plane here, plane 2, and I'm going to take a rear view of the airplane like that. Drawing in plane 2, I'm going to sketch a circle, which is what the engine hole would be. The little dash line shows me I'm on center line, and I'm visually making myself about midway. And then the diameter, the radius of a, well, this is plenty big for a F-135 or an F-119 engine. F-119 is 43 inches in diameter. So if I go 22, I've got plenty of space there for an F-135. Hit the checkbox, exit sketch, and now we're going to extrude a cutout there to make the engine hole in our model. So we go Features, Extruded Cut. Flip the direction, go 550 inches. I don't care how far I go, all the way out. Now we made a hole for our engine in the back of our airplane. Alright, so those are some of the things, the basic functions we use in SolidWorks to define an airplane. And I'll leave it to you to figure out how to define the butterfly tail or the vertical tails. You would do it by defining planes and making more wings that go in the vertical direction with sketches up here and a plane down here and another sketch down here at the right locations. Last thing I'm going to do is edit this inlet. I don't like the way it looks there. So I'm going back to that. I'm going to right click and I'm going to undo my excessive angle there. I want it to just kind of match up. That's not the right sweep angle, but I think it looks better than it did. And again, in another video we'll show you a better way to draw inlets like that.